We are live now.
Okay. Good afternoon, everyone. Can someone just reply me that am I audible? Okay. Good afternoon, everyone. I'm Professor Dipali Shrikhande. I'll be taking your pre-placement training session on fundamentals of software engineering SDLC models. Okay. So basically, what do you mean by a software? A software is nothing but a piece of code, right? That works to automate the things. A software is instructions that tells the computer that what to do and how to do it, right? So basically there will be a user, then there is an application software which we are using. So in case of right now we are live streaming, right? So the application will be the Microsoft application, right? There will be an operating system, and based on that operating system, there will be a hardware, right? So the thing is, on a hardware, there is an operating system. On that operating system, many application software runs that are being used by the user. So this is basically the flow for software. What is the software? So software comprises of the entire set of programs, procedures, routines associated with the operation of a computer system. So this is basically the software is. Okay. So let's start with the next. What do you mean by the exactly the definition of a software? So software is a product that software professional build and then support over a long time, right? So we are surrounded by the softwares basically. So there are many more softwares that are coming in a market and going, many more applications that are coming and going. So basically what software involves? Software involves the basically instructions. What do you mean by instructions? Instructions are nothing but a computer program that when it is executed, it provides the desired features, functions, and performance. Next is software has a data structure. What do you mean by data structure? That enables programs to store and manipulate the information so that the less memory can be used, right? So that will be provided by the data structure. And the third thing is documentation that describes the operation and use of a program. So basically, whenever you purchase any type of a product or any product that has a software in it, it can be a camera, it can be a fridge, it can be an washing machine. It comes with a user manual, right? That how to use it and how it can be, so functions are supported. So that is nothing but documentation, so that the person who is not from the IT industry, who is new to that thing, can easily use that software, right? So basically the software is a product that software professional build and then support over a long time. And software involves instructions, data structures, and documentations. So instructions are the computer programs, data structures are basically to store and manipulate the information, and documentation is something that describes the operation and use of that program. So this is basically what the software is. The next is different software categories. So the first software is nothing but a system software. A system software is nothing but the main software by which the system is been in use. So that is nothing but your system software. The next is your application software. So we are surrounded by applications, right? We can call it as the Microsoft applications, then PowerPoint, Word, all those are nothing but the application that makes us ease of use to use that application and to provide the information. That is nothing but your application software. Third is your engineering software. What do you mean by engineering software? There is suppose you can say institute where you need to have that data in a centralized manner, then it can be engineered in the, or it can be in customized the way institute wants it. So that is nothing but your engineering software. Embedded software, if you have a suppose particular set of hardware or embedded system, that system needs a software to run that hardware, right? So that is nothing but your embedded software. A product line software. There is suppose a big industry where manufacturing is going on, and to have that product line in place, we need to have a product line software. Then it comes the web applications, the most common applications softwares, right? We are surrounded by the web applications website on which the internet is needed to use that application. So those are nothing but my web applications. And the last and most important is the AI application. Apart from this, there can be many more applications, but these are the main software categories through which softwares can be used. The next is, what do you mean by software engineering, right? The term software engineering is basically surrounded by the multiple functions, multiple things that are required for a software to be built. So it is an application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of an software. So what do you mean by software engineering is? A software engineering is the application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of the software. So whenever we start with a software product, if suppose I am a customer and I wanted to build a software for my own company. So suppose I have chosen a XYZ company and I want that company to develop my software. So the process starts from the requirements. So what do you mean by requirements? The company employee will ask me my requirements, that what do you need? What are you needed? What is the functioning going on in your company or in your business? So based on those requirements, system can be analyzed. Then system design. Based on the analysis and requirement, design of that software has been made. Based on that design, coding has been taken place. Then after the coding, there will be the testing to check that whatever requirements that have been given by the client are satisfying or not. So after testing, a product has been ready for the deployment, right? The product has been given to the customer. After product has been given to the customer, maintenance will be in place, so that if there are any updates or any new requirements need to be added as per the time goes on, then it can be added. So this is basically the task in the software engineering. I hope you understand this. Then what do you mean by a software as a process? software is basically a process, and a process is a collection of activities, actions, and tasks that are performed when some work product is to be created. A purpose of a process is to deliver the software in timely manner with the sufficient quality to satisfy those who have sponsored its creation and those who will be using it. So processes need to be set in terms of software engineering so that there won't be any improper use of software. Okay. So the next part is, what are the generic process framework? There are five generic process framework activities that are there in software engineering. So the first is communication. Most important thing whenever we are building anything is the communication. So what do you mean by communication? Communicate with the customer to understand the objectives and gather the information. If suppose I'm communicating with the client, I have my own industry and I'm communicating with the client to get to know in a better way that what is actually needed to that customer. So communication is a first process framework activity that comes under requirement gathering, and requirement gathering, the main part is communicating with the customer to get to know that what is the objective, what are the requirements that have been there to the customer. The next process framework activity is planning. So whenever we have the requirements in this place, that I have the to-do list, that this is the requirement, these all things are needed in the software, then I can plan those things. So planning creates a map that defines the work by describing the task, risk and resources, work products, and work schedule. So planning will tell me that how many tasks are there, what can be the risk that may happen in that task, what are the resources that are needed. Resources can be in terms of the work power, in terms of the hardware requirements, in terms of the skill persons, in terms of the different applications that are required. So those are basically my resources. So if I have the planning in my place, so that I can plan for the resources very well, so that there won't be such things that I have managed the resources for a month, but those resources are not used. So planning needs to be in its place. The next thing is modeling. Modeling is nothing but creating a sketch that how it looks like architecture and how it is essential part that fits together to the other characteristic. So modeling is nothing but after communication, after planning, I have all the tasks in my place. So I can model that. I'll start with first background requirements, then I'll start with the front end requirements, then I'll start with the some functionalities which are basic, just like a login page or a registration page or something else. So modeling will tell me that how the task can be modeled or can be designed. After designing, after modeling, it comes to the construction phase. So modeling is the third phase, fourth is the construction phase. Construction is nothing but the code generation and testing. So whenever I have the design ready, I have the look and feel of my software is ready, I can generate that with the help of code. So coding is nothing but it can be in any language, right? So after the coding, my whole software is ready. As soon as, suppose this is my whole software that is divided in suppose 4 parts, that is 1, 2, 3 and 4. Okay, so suppose my part 1 is under coding, right? So as soon as my part 1 has been completed, the part 1 will go to the testing. Whenever the part 1 has been tested, simultaneously the part 2 is there in the testing part, right? So as soon as my parts are completed, the whole product can be tested. So this is nothing but my construction phase. And the last step is deployment. As soon as my testing is completed, testing is done to check the quality. So as soon as my testing is completed, it is delivered to the customer who evaluates the products and provide the feedback based on the evaluation. So if the question comes like, question has been asked like, what are the generic process framework activities? Then these are the communication, planning, modeling, construction, and deployment. Based on this generic process framework activities, there are different software development lifecycle models that are available. Okay, so these are basically my generic process framework activities. This 5 process framework activities can be used to all software development, irrespective of its application domain, irrespective of its size of a project or a complexity or a efforts or etc. For many software projects, these process framework activities are applied iteratively as the project progresses. As per the need, these process framework activities are applied. Each iteration produces a software increment that provides a subset of all software features and functionalities. Okay. The next is, what do you mean by the software development life cycle? Okay. So if you can see over here, requirements, analysis, design, coding, testing, and deployment. The generic process framework activities that we have seen are part of basically the software development life cycle. Okay, so based on those generic process framework activities, the software development life cycle has been designed. So if you can see in the diagram, the requirements are nothing but my first step in the software development life cycle. So what happens over here? Just a second. So suppose this is my customer and this is my employee. Okay, so both are communicating to each other to gather the requirements. Then those requirements are being documented in the form of SRS. What do you mean by SRS? SRS is a software requirement specification document. Whatever requirements that have been discussed between the client and the employee are being documented in the form of SRS. Okay, there are multiple templates available for the SRS as per the need of a project, as per the company policies. Those SRS can be developed. Okay, as soon as my requirements are documented, SRS has been the first step that has been given to the analysis. What happens in analysis? In analysis, all the requirements are basically analyzed. They are being checked for its feasibility. So what do you mean by feasibility? Feasibility is nothing but, is it feasible? Is it needed? Is it actually needed for that product has been checked. Just a second. So there are multiple analysis models are there based on which we can check that what are the primary requirements, what are the secondary requirements, what are the top priority requirements, based on which different models can be chosen, based on which different reports can be generated. Okay, the next step is designing. So as soon as my analysis step is complete, a design takes place. A designing is nothing but designing your backend system, that how my data can be stored. It can be stored on a cloud, or it can be stored locally on a machine, or it is a client server architecture, how the front end will be handled, that is it through the Android application, or is it through the desktop application, or is it through the web application. All those things are checked in the design, and as per the requirements, as per the analysis that has been done, the designing takes place. As soon as my designing takes place, it goes to the coding phase. The each and every part of my design, suppose this is my first, this is my second, this is my third, this is my fourth, this is my fifth. These are different modules of my project. So all those modules have been coded or have been generated. As soon as coding takes place, it has been tested for its quality. Whenever I am coding something, it may happen that one module is dependent on another module for its input, right? Or it can happen that there are multiple modules which are giving as an input and one module that produces the output. So it might happen that there might be some lag or there might be some errors. So all those errors can be tested using multiple testing techniques. There are multiple testing techniques available, like alpha testing, beta testing, unit testing, integration testing, black box text testing, white box testing, acceptance testing. Multiple testing strategies are applied on a piece of code that has been generated, so that the software that comes as a whole product and which has been given to the customer will be the quality product. Okay, so all those things have been tested. As soon as my testing phase completes, that my software is ready for the use to the customers, it has been deployed. So what do you mean by deployment? Whatever software that has been developed till now is in a company environment, or it is in a it is supported by all the infrastructure that has been needed. Whenever it has been deployed, it has to be checked that all the things that are needed to run that software are in its place or not. So that is nothing but my deployment. Okay, so this is my sixth step. Okay, so we'll quickly look through what all those things are saying. Okay, so requirement gathering and analysis. So business requirements are gathered in this place. So business requirements are nothing but the requirements that have been needed. A meeting with a manager, stakeholders, and users are held in order to determine the requirements, like who is going to use the system, how will they use the system, what is the data to be an input to the system, what should be the data be output by the system, so that we can gather these things and we can analyze those things based on which I can develop my system. After the requirement gathering, these requirements are analyzed for their validity and the possibility of incorporating the requirements in the system is checked. Or finally, the SRS, that is requirement specification document, is created, which serves the purpose for guiding the next phase of the model. The next phase is design phase. So basically, as per the diagram, first and second phase has been combined over here. The second is design phase. The design phase, the system and a software design has been prepared from the requirement specification, which are studied in the first phase. The system design helps in specifying what type of a hardware is needed, how much a RAM should be there, how much a memory is been needed. So those are nothing but my system requirements, and also helps in determining the overall system architecture, whether we need the client server architecture or whether we need the web application or whether we need the Android application, based on which the system design and software designing takes place. After the system and software design, it serves as an input to the next step of a model, that is implementation or coding. On receiving the system design documents, the work is divided into modules called as units, and actually coding starts. So basically what happens in coding, suppose, okay, I'll just give you the example. Suppose this is my whole project, okay? This is my whole project. As per the requirements of an customer, the tasks are moduled in suppose 4 parts, 1, 2, 3, and 4, okay? We'll start with the part number 1. As soon as coding starts for the task number 1, then parallelly it can happen that task 2 is also is in its development state, part 3 is also is in development state, and part 4 is also in its development phase. That is nothing but my 4 different teams are working on the development of the product, okay? But in this phase, it might happen that a module number 2 takes input from module number 1, okay? So Whenever it happens that team 1 is working on model number 1 and team 2 is working on model number 2, team 1's output will be given as an input to team number 2, right? So it might happen that if a output of a team number 1 had some error, and that error will get propagated in model number 2. So that's the reason we need the verification and testing. So after code is developed, it is tested against the requirement to make sure that the product is actually solving the needs that are gathered during the requirement phase. So suppose in requirement phase, I have 1, 2, 3, up to 10 requirements. So in testing phase, it has been checked that requirement 1, yes, satisfied. Requirement 2, yes, satisfied. So that I can check all the requirements that have been stated by the client are been covered. During this phase, unit testing, integration testing, system testing, acceptance testing, etc. are done to check the systems so that the product that have been developed is a quality product. Okay. The next is deployment. Once the software testing phase is over, there are no bugs or errors left in the system, then the final deployment process starts. Based on a feedback given by the project manager, the final software is released and checked for the deployment issues, if any. Okay. So in this phase, the deployment, the software has been deployed to the client. Okay. So this is basically my SDLC model is. The next part is your maintenance. Once the system is deployed, the customer starts using the developed system for the following activities may occur. A bug fixing. A bug fixing after all the things that have been done. It might happen that still there are few bugs that can be reported because of some scenarios which are not tested. Okay. Upgrades. Upgrading the application to the newer version of a software. So I can give you one of the example. Whenever we are using our mobiles or whenever we are using your systems, after particular time, suppose after a 1 month or a 15 days, updates come for the software, right? What are those updates? Whenever a person reports any issue, those issues have been taken care that the software won't happen, won't hamper the main system, and updates, the patches are released for that system, so that similar type of a condition happens, then there will be a solution. So after particular time period, for the maintaining purpose, the updates are released. Okay. The main focus of this SDLC phase is to ensure that the needs continue to met and the system continue to perform as per the specification mentioned in the first place. Okay. So this is nothing but my maintenance. Then the question comes that why SDLC? Why do we need SDLC? Okay. So there are a few reasons that we need SDLC models. Okay. First, it offers the basis for project planning, scheduling, and estimating. Whenever we have the SDLC in its place, that is software development life cycle in its place, a project planning, scheduling, and estimating helps me to understand what are my project requirements. Second, it provides framework for standard set of activities and deliverables. Okay, just a second. Just a second. So the third is it's a mechanism for project tracking and control. So whenever, suppose I need to track that what is the status or what is the progress of my project, I can track the project so that I can have the things that will I complete my project on time? Do I need any increased budget or do I short for the budget, I can track those things. The fourth thing is increases the visibility of a project planning to all involved stakeholders of the development process. So stakeholders are nothing but the person who is using that project, who is developing that project. In short, the person who is related to that project is nothing but your stakeholder. Okay. Fifth thing is increase and enhance development speed. Whenever I have the proper processes in its place, I can have the proper development going on, right? So if there are any risk that may happen, I have the policy to overcome that risk in its place. Improved client relation. Whenever communication takes place between client and a company employees, the improved client relation will help me to understand that what client actually needs. It helps you to decrease the project risk and project management plan overhead. So this is the reason why do we need SDLC. Okay. So we are going to see the SDLC models. Okay. So there are different SDLC models like a waterfall model, RAD model, iterative model, incremental model, spiral model, prototype model, and V model. Okay. So we are going to see the 7 models now, and for each and every model, I'll be describing you what that model is, what are the advantages, what are the disadvantages, and when to use that model. Okay. So we'll start quickly with the waterfall model. If you have any questions, you can type it in a chat box and I can answer them towards the end of the session. Okay. Just a second. So the waterfall model was the first process model to be introduced under software development lifecycle. So it is also referred to as a linear sequential lifecycle model. It is very simple and easy to use. In this phase, the one phase must be fully completed before the next phase begins. This type of model is basically used for the projects which are small and there are no uncertain requirements. That is, there are no changing requirements. It is used when requirements are well understood and the risks are low. It is best understood by the upper management. This model, the testing starts only after the development is complete. That means each and every phase starts only after the previous step is complete. There is no overlapping of phases. Okay. So what happens in this? Just a second. Yeah. So this is nothing but my waterfall model. If you can see over here, a communication, planning, modeling, construction, and deployment. These are my generic framework activities, right? So these generic framework activities are part of my waterfall model. Under this generic process framework activities, there are certain activities conducted that makes it unique to that waterfall model. So this is first is project initiation and requirement gathering. So what happens in communication? In communication, a customer, the employee, and the client have the proper communication to gather the requirements. So requirement gathering is nothing but a part of communication. In planning, as per the requirements, so if in the requirement gathering, in the communication plan, suppose I have stated 50 requirements. Okay, I have stated 50 requirements. In planning step, on those 50 requirements, I'll estimate how much resources are needed for that 50 requirements. I'll schedule that which requirements are of top priority, which requirements are of less priority, which requirements have a certain risk, and all those things. So all those things can be estimated and scheduled. Based on the scheduling, I can commit to the customer that suppose in 2 months of time period, I can deliver the system. So this is nothing but my scheduling. Okay. The next step is tracking. So tracking all the requirements and things will help me to understand what is my project status. Okay. After the planning process has been done, we go to the modeling phase. In the modeling phase, we have analysis and design. So a system design has been taken place. Okay. So what happens in system design? Whatever the system is there, that designing, that how much memory is needed, what kind of backend, what kind of a front end has been required, all those things are checked. Okay. The next step is construction and coding. In construction, coding and testing takes place. So coding and testing goes hand in hand. As soon as I develop a code, that code has been tested for the quality. As soon as all the models are tested, all the modules that have been there are tested, and my full project is ready for the deployment, a deployment process starts. So in waterfall model, the main feature is whenever I need to work on a construction phase, my all three phases, that is modeling, planning, and communication, needs to be 100% completed. There won't be any change in requirements. Okay. So within those 2 months of time period, if suppose there are any requirements that have been changed, then it cannot be added in my system. Okay. Then my delivery takes place and support and feedback will be taken from the client. So what are the advantages of a waterfall model? It is easy to understand and easy to use, provides the structure to inexperienced staff. So if suppose there are employees who are new in the company, who does not have experience to work on anything, then it is a best model that a person can work with this model. Sets the requirement stability, because there are no change in requirements, right? So requirements can be freezed. Okay. So I have a proper look that I need to focus on these many requirements only. Okay. Good for the management control, because it takes as a planning, staffing, and tracking of the project. So it is good for the controlling. Okay. Works well when quality is important over the cost or a schedule. So these are my advantages of waterfall model. What are the disadvantages? All requirements must be known upfront. That is the biggest disadvantage of waterfall model. So what happens in this? All the requirements must be known upfront. Can give a false impression of a progress. So what happens? If suppose I am in the coding phase, okay, so I do not know how much time is needed, because it may happen there are, due to unexperienced staff or something like that, if any risk happens, that how much time is needed cannot be guessed, right? So does not reflect the problem solving nature of a software development. Integration at the end is one of the big bang, because there are no modules, right? Each and every module must be completed before another module starts. So integration at the end is a difficult task. Little opportunity for a customer to preview the system until it's too late, because till the time my whole project is ready, I cannot deploy it to the customer, right? So customer does not get insights on what is happening actually in that system. Okay. So this is nothing but my waterfall model disadvantages. Then when to use this model? When requirements are very well known. The first thing, product definition is stable. That is, there are no change in requirements, then I can use this model. Technology is very well understood. A project is short or a new version of an existing product needs to come into the market. Porting an existing product to the new platform, then I can use this waterfall model. Okay. If you have any questions, you can type it in a chat box. We'll take it towards end of the session. Okay. Then we'll move to the next model. That is incremental and iterative model. So there are many students who have the confusion between what do you mean by incremental model and what do you mean by iterative model. So this picture will clear you what do you mean by incremental and iterative models. Okay. So if you can see over here, okay, there is a picture. Okay. A picture has been thought by the customer, that a customer says that my software needs to look like this and my software should work like this. Okay, that is a thought process of the customer. Okay, what happens with an incremental model and iterative model? In incremental model, that process, that picture is divided into 4 parts. Okay, that is first, second, third and fourth. With the increments, that is increment number 1, increment number 2, increment number 3, that product will be divided in different parts. Okay, so if suppose in increment 1 and 2 part has been completed, in increment number 2, third part will be added. In increment number 4, fourth part will be added. So likewise, if suppose I need to draw a picture, I need to make a software, then I divide it in 4 parts, 1, 2, 3, 4. In each increment, I'll develop the whole module and then I'll go to the next module. Okay. I'll develop the second module, then I'll go to the third module. So in each and every increment, a part of a module has been developed. Okay. So this is basically my incremental model. And now what is my iterative model? So iterative model is nothing but whenever you are in a school phase, right? We need to draw something. We first draw it by a pencil. Then we fill the colors. Then we do the borders. Then we'll make the finishing, right? So that is nothing but my iterative model. If suppose I need to develop a system using iterative model, I'll first take the backend processes. Then I'll choose the front end processes. I'll develop the user interface. Then I'll add the minimum functionalities and I'll then refine those functionalities. So that is nothing but my iterative model. So this is nothing but a pencil sketch, then added the some colors, then added the functionalities, right? So this is nothing but my iterative model. So if you remember these 2 pictures properly, then there will be no confusion ever in your mind that what do you mean by incremental model and what do you mean by iterative. I hope it's clear. So we'll go to the next part. That is incremental model. Just a second. So in incremental model, the whole requirement is divided in a various builds. That is nothing but your increments. Multiple development cycles takes place here by making it a multi-waterfall cycle. Cycles are divided into smaller and easily manageable modules. Each module passes through the requirement, design, and implementation and testing phase. A working version of a software is produced during the first module. So you have the working software early during your software development lifecycle. Each subsequent release of a module adds the functionality to the previous release, and the process continues till you complete the full system. So as soon as my first increment is completed, then I can have a look of how my software will look like. Okay, so this is nothing but my incremental model. Okay, so requirements are divided into different builds. On those builds, different designing and development takes place, testing takes place, and implementation takes place. After that, the integration will be done. So what are the advantages of an incremental model? So generates the working software quickly and early during the software lifecycle. This model is more flexible and less costly to the change of scope and requirements. It is easy to test and debug during the smaller iteration. In this model, customer can respond to each and every build. As each and every build is a separate increment, a customer can give a proper input to each and every increment. Lowers the initial delivery cost. As in first increment itself, I can have the working software, a look of a working software ready, right? So this is nothing but the advantage. Easy to manage the risk because risky pieces are identified and handled during the iterations. Okay, so this is my advantages of incremental. Then what can be the disadvantages? This needs the good planning and designing, because whenever we are dividing the modules in different increments, we need to have the proper planning and designing at its place, because it may happen that one module is dependent on another module, then those requirements need to be stuck together. Needs a clear and a complete definition of the system before it can be broken down and built incrementally. A total cost is higher than waterfall model. It is a disadvantage of incremental. Then when to use this model? This model can be used when requirements of a complete system are clearly defined and understood. Major requirement must be defined. However, some details can be evolved with the time. There is a need to get the product in a market early, or a new technology is being used. A resources needed with the skill sets are not available. There are some high risk features or a goal, then we should use the incremental model. The next is iterative model. Iterative lifecycle model does not attempt to start with the full specification of requirements. Instead, development begins by specifying and implementing just a part of a system, which can be then reviewed in order to identify the further requirements. This process is repeated in producing the new version of a software for each and every cycle of a model. So in each and every iterations, new functionalities will be added. So it is easy to add new requirements with the help of iterative model. So what are the advantages of iterative model? Can track the defects at the early stage. Reliable user feedback, because I have each and every iterations have some specific functionality. So I can show it to the user and get the feedback. Less time is spent on documenting and more time is given to the design. That is my advantage. What can be the disadvantage? Each phase of an iteration is rigid with no overlaps. Costly system architecture or design issues may arise because not all requirements are gathered upfront for the entire life cycle. When to use the iterative model? Requirements of the complete system are clearly defined and understood. Then we should use the iterative model. when the project is big or a major requirement must be defined. However, some details may evolve with the time. Then we can use the iterative model. Just a second. Hope these three models are clear to you. That is waterfall model, then incremental model, and now iterative model. Four more models are remaining. The next is your RAD model. As the name suggests, rapid application development. It is an incremental software development process model, which is a high-speed adaptation of the linear sequential model in which the rapid development is achieved using a component-based construction. That is, if requirements are very well understood, the project's scope is constrained, and the RAD process enables the development team to create a fully functional system with a short time period, such as 60 to 90 days. So, whenever I have the time limit that there is a competition in a market that who will launch this product first, okay? So, in suppose 60 to 90 days I need the product in the market, then I can use the RAD model, which is based on the incremental software development. So what happens in RAD model? As soon as my communication and planning has been done, a modeling and construction is worked in different teams. That is team number 1, team number 2, team number 3. These things are going on in parallel. As soon as team completes its work, it has been integrated at the end and it has been ready for the deployment. What happens in teams? So it basically, each and every team works on business modeling, data modeling, process modeling, application generation, and testing and turnover. So what happens in business modeling? Just a second. The information flow is identified between various business functions of the software. Okay. The data modeling, the information is gathered from the business modeling. It is used to define the data objects that are needed for the business. Process modeling. Data objects defined in a data modeling are converted to achieve the business information flow to achieve some specific business objectives. Descriptions are identified and created for the crude data for the data objects. Crude is nothing but create, replace, update, and delete the data object. Application generation. Automated tools are used to convert the process models into the code and the actual system. Testing the new component and all the interfaces. So basically, RAD models make use of existing software components and that can be used to generate the new system. Okay, because we have the time limitation of 60 to 90 days. Advantages of the RAD model. Reduce development time because we have the time limit of 60 to 90 days. Increase the reusability of components. If suppose I have the different similar system available, then I can reuse the components from that system to make the new system. Quick initial reviews occur because we do not have much time. So reviews occur on periodic basis. Encourages the customer feedback. Integration from very beginning solves the lot of integration issues which may happen at the end. Disadvantages. Depends on a strong team and individual performances for the identifying the business requirement. So identifying the business requirement by different team members can be a disadvantage. Only system that can be modularized can be built using RAD model. That is, whenever we have the models or we have the different component based system, then only I can use those components and models in the RAD. If I do not have modularized system, then I cannot reuse those components in the RAD. Requires highly skilled developers and designers. High dependency on a modeling skill. Inapplicable to the cheaper project as the cost of modeling an automated code generation tool is very high. Then when to use this model? We can use a RAD model when there is a need to create the system that can be modularized in 2 to 3 months. It should be used if there is a high availability of designers for modeling and the budget is high enough to afford their cost along with their cost of automation code generating tools. RAD SDLC model should be chosen only if resources with a high business knowledge are available and there is a need to produce a system in a short time span. Okay, then only we can use the RAD model. The next is your most important model, that is spiral model. The spiral model is similar to the incremental model with more emphasis on a risk analysis. A project repeatedly passes through phases in iterations called as spirals. Okay, a baseline spiral start in the planning phase, requirements are gathered, risk has been assessed. Each and every subsequent spiral built on a baseline of a spiral model. Okay, so this is basically the pictorial representation for the spiral model. Just a second, I'll explain you. I'll just change the paint color. So this is, if you can see over here, this is basically my first spiral. Okay, this is basically my second spiral, which is built on a first spiral. So what happens in this? So this is my first customer communication, second planning, third risk analysis, fourth engineering, fifth construction and release, and sixth is customer evaluation. Okay, this is basically the things that are been there. Okay, what happens in this? Whenever we are using spiral model, a customer communication takes place. That is, a requirement gathering takes place. On that, the planning takes place. On that, the risks are analyzed. After risks are analyzed, those requirements are engineered. That is nothing but those requirements are designed. Then the construction and release happens and the customer evaluation takes place. I'll give you the one of the common example. Whenever you started using WhatsApp, okay, first, whenever the WhatsApp came into the market, it is just a chatting application, right? We just used to send the text messages and images. Then videos are added. Then after a particular time, there is a functions of voice call and video call are introduced, right? After a particular time, you can send the documents. After a particular time, a feature of sending the live location came into the existence. So what happened basically? Whatever my basic features are that are in its place, a new features are added along with the each and every spiral. So as soon as any update comes, the base thing is over there only. All the updates are added on the base. Okay, so this is nothing but my spiral model. What are the advantages of a spiral model? High amount of risk analysis, hence avoidance of risk is been enhanced. Good for the large and mission critical projects. A strong approval and documentation control. Additional functionality can be added at the later date. A software is produced early in the software lifecycle. As soon as first spiral gets over, the customer feedback is taken on a first spiral. So my software is produced early in its life cycle days. So each and every requirements, adding the requirements or updating the requirements is easy with the help of spiral model. What can be the disadvantages? It can be costly model to use as we need the risk analysis. The proper tools to analyze those risks are needed, right? So it can be the costly model. Risk analysis requires highly specific expertise because analyzing the risk is not a easy task. A product success is highly dependent on a risk analysis phase. Doesn't work well for the small projects. When to use the spiral model? When the cost and the risk evaluation is important, then we can use the spiral model. What happens in this basically? When we have a budget in its place, suppose for an XYZ project, the some part of a cost has been assigned, but that cost is not enough. Then we need to have the cost monitoring. In that case, I can use the spiral model. Medium to high risk projects. A risky project in its development, then I can use the spiral model. So that if that risk happens, updates can be done easily with the help of adding the new spiral. That's the reason it is useful for medium to high risk projects. Long-term project commitments unwise because potential changes to the economic priorities. Users are unsure of their needs, then I can use the spiral model because requirements can be added anytime during the spiral. Requirements are complex. A new product line in its place or a significant changes are expected. That is research or exploration projects are there. Then I can use the spiral model. The next is prototype model. The basic idea here is instead of freezing the requirements before designing or coding can proceed, throw away a prototype is built to understand the requirements. So what do you mean by prototype basically? If you ever visit any construction site or an office of a construction site, then there is a prototype of that building or that construction site has been kept just to see that how that building will look alike. So similar to that, if suppose I need to have a look and feel, that actual feel of my how the system will look alike, then I can build a I can use a prototype model. This prototype model is developed based on a currently known requirements. By using this prototype, a client can actually get the actual feel of a system. Since interactions with the prototype can be enabled the client to better understand what the requirements of the desired systems are. A prototyping is an attractive idea for complicated and large systems for which there is no manual process or existing system to help in determining the requirements. The prototype are usually not complete system and many of the details are not built in a prototype. The goal is to provide system with an overall functionality. So this is basically my prototype model looks like. We start with the requirement gathering. As soon as my requirements are gathered, a quick design takes place that how those requirements will look alike in if suppose that system needs to be designed. After that quick design, a prototype has been built. That prototype will be shown to the customer and a feedback has been taken from the customer. If that feedback is positive, we can refine my prototype. If there are some changes, I can quickly redesign those changes. I can again add those changes to the prototype. I'll again show it to the customer and refine my prototype. So this is my first step, that is requirement gathering. This is my second step, that is quick design. This is my third step, that is prototype. This is my fourth step, that is customer evaluation. This is my fifth step, that is refining prototype. So after quick design, it goes to the building prototype, then customer evaluation, then refining prototype. Till the time there are changes from the customer, this process goes on and on and on. As soon as my customer says, okay, now product can be developed, then we start the developing that product. Okay, and that will be stopped at the end. So this is nothing but my prototype model. What are the advantages? Users are actively involved in the development, because in all the previous models, a customer evaluation or a feedback from a customer or a user will be taken as soon as the product or a part of a product is developed. Okay, but we are not developing a full product over here. We are just developing a prototype. So users are actively involved in a development. Errors can be detected much earlier, because as soon as we get the customer feedback, errors can be detected and we can work on those errors. Quicker user feedback is available, leading to better solution. Missing functionalities can be identified easily, because this loop goes on, right? Quick design, building prototype, customer evaluation, and refining the prototype. This goes on and goes on till the time I can have the proper system in its place, right? So missing functionality can be identified at any stage, and those can be better identified with the help of prototype model. The next is your disadvantages. Prototype model leads to implementing and then repairing the way of building system. So it requires more time. Practically, this methodology may increase the complexity of a system, as the scope of system may expand beyond its original plans. Incomplete application may cause an application not to be used, as the full system was designed incomplete or adequate problem analysis. So these are the disadvantages. Then when to use this model? When the desired system needs to have a lot of interaction with the end users, typically online system or a web interfaces that needs the high amount of interactions with the end users, then the prototype model is best suited. Excellent for designing the good human-computer interface systems. And the last model is V model. So V model is highly disciplined SDLC model, in which there is a testing phase parallel to the each and every development phase. So we have seen the development phases, right? That is communication, planning, modeling, construction, and deployment. So each and every phase, we have some set of testing activities that has been there. The V model is an extension of the waterfall model, in which testing is done on each and every stage, parallel with development in a sequential way. So this is nothing but my V model. The V model of a testing was developed where for each and every phase, the development life cycle, there is a corresponding testing phase. It is also known as verification or validation model. So this is nothing but my V model lookalike. So whenever I have the system requirement or analysis phase, I have the system testing in its place. I have the design phase. I have the integration testing. A low level designing, that is different models need to be designed. I have the unit testing phase. And as soon as all those things are in its place, I can have the coding. So whenever I need to develop the code for a different module, that has been unit tested. I make a high level design, that is multiple modules are integrated together, I have the integration testing. As soon as all the modules are developed and a product is ready for the deployment, a system testing in its place. So left side of a model is a software development life cycle, and right side of a model is my software testing life cycle. The entire figure looks like a V, hence it is named as V model. So we'll quickly see the differences between the SDLC models. There are multiple parameters based on which we can differentiate between the SDLC models. So these are the properties of a model, and we are basically differentiating 4 models, that is waterfall model, incremental model, spiral model, and rad model. Planning in an early stage. Yes, waterfall model we can plan in an early stage. Incremental model, yes. Spiral model, yes. Rad model, no. Because rad model is a rapid application development and we reuse the component. So planning in early stages does not happen in a rad model. Returning to earlier phase. Waterfall model, it is not possible because in waterfall model, each and every previous step needs to be completed Okay. In incremental model, yes, returning to the previous phase is available. Spiral model, yes, it is available. With the rad model, yes, it is available. Okay, just a second. The next is handle the large project. It is not appropriate to handle the large project in case of waterfall, incremental, and rad model. But yes, in case of spiral model, it is available because we can add spirals as soon as my requirements are added. A detailed documentation is necessary in waterfall spiral model. It is limited in rad model and incremental model. As per the cost, spiral model is the most expensive model because whenever we are building the spirals, we have the baseline in its place, right? So the cost has been added over and over as soon as we add the new spiral. Okay. But in case of waterfall, incremental, and rad model, it's low. Requirement specifications are taken in a beginning in waterfall, incremental, and spiral model. But in rad model, it is time box release because we have the limited time period, that is 60 to 90 days. Flexibility to change. It is difficult in waterfall model because there are no changes can be added in the waterfall model, but it is easy in case of incremental, spiral, and rad model. User involvement. In the waterfall model, it is at the beginning in the requirement phase only. In the incremental model, it is intermediate at the increment level. In the spiral model, it is very high because each and every spiral has a customer feedback. So user involvement is high. And in the rad model, it is only at the beginning. Maintenance. A maintenance is a list in a waterfall model. Incremental model promotes the maintainability. It is rad model, it is easily maintained, and spiral model, it is typical. That is nothing but a maintenance is in its place. Whenever we need to add anything or update anything, we can easily add the spiral. Okay. Duration is long in a waterfall model. In an incremental model, it is very long as each and every increment needs to be completed on time. Spiral model, it is long, and rad model, it is short because we have the fixed time period, that is 60 to 90 days. We'll see few more parameters with respect to these models. Framework type. A framework type is a linear type. Incremental is an linear plus iterative type. Spiral is linear plus iterative and RAD is linear. Testing is done after the completion of coding phase in waterfall model. Testing takes place after every iterations in incremental model, in spiral model at the end of engineering phase, and in case of RAD model after completing the coding phase. Overlapping the phases. No, in waterfall model, we cannot overlap the phases. We cannot overlap the phases in spiral model, but we can add new spirals. In incremental and RAD model, yes, it is available. There is a parallel activity can be done. Maintenance, it is least maintainable. RAD model is easily maintainable. Incremental model is maintainable, and yes, spiral model is also maintainable. Reusability. RAD model, yes, we can use. Spiral model to some extent we can use, even with the incremental model. But waterfall model is least reusable. Time frame, it is very long and short in case of RAD model. Working software availability at the end of life cycle. That is, as soon as we complete the life cycle, I can have the working software availability in case of waterfall model. At the end of every iteration, that is, as soon as my first increments has been released, I can have the working software availability at the end of every iteration. That is, as soon as my first spiral is complete, I can have the actual feel of how my system is. And it is same in the part of RAD model at the end of life cycle. Objective. It is high assurance, it is rapid development, high assurance and rapid development. Team size. Waterfall models require a large team. Incremental model does not require a large team. Spiral model requires a large team. RAD model requires a small team as the time period is low. Customer control over the administration, very low. But yes, it is present in case of incremental, spiral and RAD model. So that is about all your SDLC models. Okay. So in today's session, we have seen what do you mean by software, what do you mean by software engineering, what do you mean by generic process framework activities for software engineering. We have seen the SDLC models, that is what are the different SDLC models, why those models are needed, and all those things. Then we have seen the SDLC models, that is 7 models we have seen, that is waterfall model, incremental model, iterative model, RAD model, spiral model, prototype model, and V model. So if you have any queries, you can reach me at dipalishrikhande@vit.edu.in, or if you have any questions, you can type it in a chat box, we'll answer them. Typically for the interviews on an SDLC models, a question may be asked in the type of a scenario based question, that a scenario will be given and they may ask that what model you will be choosing for that scenario. Okay. Or it may ask that what is your final year project and which type of a model is best suited for your final year project. So you just need to justify that what your project is and why you are choosing your model. That needs to be answered. It might happen that they may ask that why these functions are there in this model and why these are not there, why risk analysis is not there in another models. Okay, so it is basically, the question may come like this on the basis of what your model functions are. If you can see over here, each and every model has all the generic process framework activity, but those activities are arranged in a way that each and every model makes its difference, right? So these models are important. On top of these, basically these are the traditional models. On top of these, we have the agile models that we are going to see in the next lecture on a third. So if you have any questions, you can type it in a chat box and we'll answer them. Akshata ma'am, Are there any questions in the chat box?